Okay, well now it's time to look at solving inequalities. So solving an equality or an equation, you have an equal sign in there and you want to find what value or values, in fact, will satisfy the equation. Same thing holds with inequalities, although usually with inequalities there are going to be a lot of answers. There are going to be a lot of answers that actually will satisfy the inequality. And so the question is, how do you find them all? And how do you know they're all answers? Anyway, we'll talk about this for a while, but I thought first I just would warm up to this by just thinking about the basic facts about inequalities and what you can do with the arithmetic and the algebra of inequalities. And so what better way to start than, of course, with a buffet. Okay, a little bit lame, I admit, but the truth is, if you're ever at a vegetarian buffet, which is sort of lame in and of itself, you might have sort of these two plates, right? So here this is sort of a more small, modest plate. This is a little teeny orange here. Here you have a big old Texas red, ruby red grapefruit. So in fact, you can see that this is actually larger than this. If you put this on a scale, this would weigh a lot more. Now actually, remember what this symbol means. This means that this quantity is less than or possibly equal to this one. But you can see that, in fact, I could also replace it by this stronger fact, which says that, in fact, this is strictly smaller. So remember the difference between these two things. This means that, in fact, this is less than or maybe equal to this one, whereas this just means this is strictly smaller. Okay, well, if you have an inequality like this, if you want to perform algebra or arithmetic on it, you can perform algebra arithmetic just like you would normally with an equal sign. For example, suppose that you wanted to add the same thing to both sides. That's not going to change the inequality if they're both the same. For example, suppose you want to toss on a banana. So, and these are really, very ripe bananas. These should be eaten very, very soon. You can just tack them on. The inequality still stays the same. And if you want to subtract off the same amount, like this, watch, whoop, the inequality still stays the same. Not a big deal. Now, of course, multiplying and dividing, different issue. If you want to multiply through by a pineapple, if the pineapple is positive, then you know the sign does not change. But remember, if you're looking at a negative pineapple, if you multiply or divide through by a negative pineapple, well then, of course, the sign is going to flip. Because remember, this is a classic mistake number 7, multiplying the inequality mistake. If you multiply through by an inequality, by a negative number, that inequality symbol switches signs. And remember, just because the pineapple may look positive, don't trust any unknown to be positive. Okay, well, let's take a look now at a real numerical example and not just these fake ones. So let me just get rid of these things here really fast here. Get rid of the pineapple. Get rid of these things and these things and these things and the banana. Well, this banana maybe. This is sort of ripe to be eaten. Okay. This is very good, by the way. Very good, very good. Okay. That banana was obviously from Australia, as you can see. All right. It's okay. The crew will pay, as they say in showbiz. All right, let's take a look at the following example. I got banana on my shirt, and it clashes. Okay, let me just get rid of this sign, too. Okay. All right, here we go. So let's take a look at 2 times the quantity x plus 3 less than 4x plus 10. Okay, and now what I want to do is I want to actually solve this inequality for x. So basically I'm thinking about this just like a regular equality, but the only difference is now there's an inequality involved. But the still idea is to have x by itself, x, and then either less than or greater than some number. Okay, so how to proceed? Well, the first thing I do is try to isolate all the x's. So I'm going to distribute this 2 first in order to get rid of that parentheses. So that's no problem. 2x plus 6 less than 4x plus 10. And now I'm going to proceed just like I normally would. I'll bring this 4x over to the other side. So if I subtract 4x from both sides, it's not going to change the inequality. Now, we do this very cavalierly with the equal sign. I bring it over and make it a minus 4x. But let me just make sure what we're really doing here is subtracting 4x from each side. Maybe I'll even write that down. So it's not going to change the balance of power at all. This is still going to be smaller. But now I have 2x minus 4x. That's a negative 2x. And don't forget the plus 6 is still there. And that's still going to be less than, and these cancel away, and I'm left with 10. Okay, fine. Now I take the plus 6, and I can bring it over to this side by subtracting. I'll write this in one last time just to illustrate that I'm not changing the balance of the scale at all. When I combined, I see a minus 2x is still less than, and then I have 10 minus 6, which is 4. Now I want to divide both sides by this coefficient, which is a negative 2. Aha! Now here is where the action takes place. If I divide both sides by a negative, what happens, of course, is this sign has to flip, right, because of the negativeness. So remember, now we're going to see a flipping sign, and so these cancel, and I see x is now greater than negative 2. So that's the answer. Now that may look sort of strange to you. You might say, gee, what does x equal? Like, what number does it equal? Well, it equals any number that's greater than negative 2. So this is one way to say the answer. Let me remind you of some other ways that we could say the answer in. And you might want to review these, by the way, on some of the review lectures that we have on looking at interval notation and so forth. But another way, if you look on a line graphically, what does this mean? Well, if this is a number line, and so like here is 0, and here is negative 1, and here is negative 2, then the answer is any x value that's bigger than negative 2. Can't equal negative 2 because there's no equal sign down there. So it's just anything to the right of negative 2. But we do not include that. So I put a parentheses like that to mean not include that. Another way to write this out using the interval notation would be to write negative 2, and then you can go all the way out to infinity. So I write plus infinity. And that means these are all the points that are strictly bigger than negative 2. And again, if you're not familiar with or not comfortable with this interval notation or this, you might want to watch the little review lecture on interval notation and how they correspond to inequalities. But anyway, there's the answer for this particular inequality. Let me try one last one. Suppose that I tell you that I have 2 minus 3x, and that's less than or equal to x plus 14. OK, now I want to solve this. So how would I do that? Well, let me bring this x over to that side. So now I'm going to subtract it. And I'm going to try to do this without writing in minus x equals minus x. If I subtract it over, the sign doesn't change, but I see a minus 4x less than or equal to 14. If I bring this 2 over, I have to subtract it. Doesn't change the inequality. So I now see, if I bring this over, I'll see a 12. But now I want to divide both sides by minus 4. Aha! I'm multiplying, I'm dividing by a negative. That means this sign flips over. And so what I see is they cancel here, and I'm going to see that x is now greater than or equal to, and this looks like negative 3. So what would that answer look like graphically? It's always good to sometimes think of them graphically. If this is 0, this is 1, this is minus 1, minus 2, and this is minus 3, then graphically, the solution to this will be any x value at all, any x, as long as it is greater than or equal to minus 3. So anything bigger than minus 3, see any of those points. But now I'm allowed to actually equal minus 3. That's actually allowed. So I denote that with a bracket like that. And we can denote this in interval notation as bracket minus 3 out to plus infinity. And again, if you're not comfortable or happy with want to review the bracket notation or this graphing stuff, you can just watch the little review tape that you can click on the thing below. Anyway, this is how you'd solve very basic inequalities, very much like solving regular linear equalities, but all you got to be careful of is when you multiply or divide by a negative, you got to flip the sign, and you can actually now see all the solutions. Right? Pick anything in here. For example, if you pick 0, that should satisfy this. Let's see if it does. If you plug in a 0 for x, I see 2 is less than or equal to 14. That's true. So, party time! And you can pick any point in here, and you'll see the same thing. But if you pick the point way out here, that would not satisfy this. OK, up next, we'll take a look at some even more exotic inequalities. I'll see you there.